Hi everyone, today we are going to do Math 6, Mission 8, Lesson 2, Statistical Questions. Let's look more closely at data and the questions they can help to answer. So today for our warm-up, we want you to measure the length of your pencil, then answer the question about pencil lengths in your class. I have a 10 number data set that we're going to be using. So to begin with, we need to draw our number line, and we are going to make a dot plot. So number 1 says, measure your pencil to the nearest quarter of an inch, then plot your measurement on the class dot plot. So we got to put a dot plot together. So we have 0 to 7, because that's the data that I have. So we have 1, 2, 3, 4, 5, 6, 7. And then within that, we are going to do half marks. And then it does say to a quarter of an inch, so we can do quarter of an inch marks too. Although none of our data gets to quarter of an inch today. So I have one pencil that measured at 3.5 inches. So I'll go to 3.5 and I'll put a dot. We have another at 4.5. We have one at 5. We have 4 at 6 inches. So we had 4 students who each had the same pencil. Then we have one at 6.5 and one at 7. So we measured 10 student pencils. All right, number 2. What is the difference between the longest and shortest pencil lengths in the class? Well, the longest is 7. And the difference means subtract. So longest, 7, minus the shortest, which would be 3.5 for our data set. So 7 minus 3.5 happens to be 3.5. 3. What is the most common pencil length? So that's going to be the one that has the most dots, which would be 6 inches. Find the difference, so again we're subtracting, in lengths between the most common length and the shortest. The most common length was 6, so we're going to subtract the shortest length. The shortest length is 3.5. So 6 minus 3.5 is 2.5 inches. That is our warm-up. All right, let's keep going. Activity 1. 10 6th grade students, so we've done 10 students in 6th grade, at a school were each asked 5 survey questions. Their answers to each question are shown in the table below. So this is 1, 2, 3, 4, 5. This must be the questions. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the students. So you can see student 1 answered the first question as 0, second as 12, third as 6, fourth as 6, 5 as 3. We're going to use this data to answer our questions. Number 1, here are the 5 survey questions. Match each question to a data set that could represent the student's answers. Explain your reasoning. So we have data set A, B, C, D, and E. Question 1 says, flip a coin 10 times. How many heads did you get? So looking at the data, I'm going to say no to B right away because I don't think that it's reasonable to think that every single student would get 12 heads every single time. And that's not really possible either because it's over 10. So any data set that has a number over 10 can't be in our data. Can't be right. So B is definitely out. Let's look for some more. E is definitely out because I see a 16 here and 11. So that's over 10. Also, same reasoning that I got rid of data set B for data set D is I don't think every student is going to flip the coin and get 6 heads every single time. So D is out. So now we have A and C. A's data set has 0 to 3. So the lowest data point is 0 and the highest data point is 3. So 0 to 3. And C is 3 to 8, it looks like. 3 to 8. Well, when you flip a coin, you have heads and tails. That's a 50-50 chance of getting heads or tails. 0 to 3, if we have 10 times, 50-50 would be 5 out of 10, right? So would it make sense that you only have 0 to 3 in the data set? Or would it make more sense to have 3 to 8? I think 3 to 8 is closer to 5, and so the data set C is my reason. I think question 1 is data set C. Question 2, how many books did you read in the last year? All right, so again, we have A, B, C, D, and E. Well, we don't have C because we've already used that for question 1. So how many books did you read in a year? I don't see every single student reading the exact same number of books, so we can get rid of B and D as well. Now let's look at A. Do you think you would have multiple students reading 0 books throughout the year? I don't think so. I mean, at our school we have AR, and our kids read all the time. So I don't think A is it. I think E is question number 2. Question 3, what grade are you in? Well, we surveyed 10 6th graders, so they all should be in the same grade. That to me says that is data set D, because data set D has 6s all across the board. Question 4, how many dogs and cats do you have? Ooh, okay, so we have A, B, C, D, and E. We have used C, D, and E. So we have A, and that has 0 to 3, or B, which is only 12. Do you think every student would have the exact same number of dogs and cats and that they would all be 12? I don't think so. So data set A for question 4. Question 5, how many inches are in 1 foot? There are 12 inches in 1 foot, so that has to be our last one, which is B. 2 says, discuss with a partner, how are questions 3 and 5 different from the other questions? 3 and 5. So data set D is all 6s, and data set B are all 12s. They don't have any variability, like there's no variety in it. Every answer is exactly the same. So that brings up a really good vocabulary word that we need to know. Variability. Please write this down. So variability means not every data value is the same. In D and B, every data value was either 12 or 6. So that doesn't give us variety. So variability, not every data value is the same. B and D show no variability. Variability is an important word that you need to know. All right, activity 2, task 1. Use the example of the of the statistical question and non-statistical questions to discuss the following questions with your partner. These 3 questions are examples of statistical questions. So we're going to try and figure out why these are statistical, and these over here are not examples of statistical questions. Here we go. Statistical questions. What is the most common color of the cars in the school parking lot? What percentage of students in the school have a cell phone? Which kind of literature, fiction or nonfiction, is more popular among students in the school? So these questions here can be put into groups, right? You can categorize some of them. These also take work to answer. They're not easy. You have to survey people. You have to talk to multiple people to figure out, what's the most common color of the cars in the school parking lot. So you have to gather and study data. On this side, we have what color is the principal's car? Does Elena have a cell phone? What kind of literature, fiction or nonfiction, does Diego prefer? So here, what color is the principal's car? So we're asking for a color, which it could be a group, but we're only asking for the principal's car. It's one person. So let's say that car is green. That doesn't have any variability. It's got one answer. It's not a statistical question. Does Elena, just Elena, have a cell phone? Again, that's one person. One answer. This is a yes or no, right or wrong question. Answer, I mean. So, Elena, that's a yes or no. Does Elena have a cell phone? Does she not? What kind of literature, fiction or nonfiction, does Diego prefer? That's one person. It's one answer. So, non-statistical questions are going to be easy to answer. And it's going to be about the individual. One answer, one person. Okay. Oops. Number 1 says, study the examples and non-examples, discuss with your partner. So we've just done that. Let's skip to activity 2, task 2. Read each question. Think about the data you might collect to answer it and whether you expect to see variability in the data. Complete each blank with yes or no. How many cups of water do my classmates drink each day? So we're asking for cups of water and classmates. That's more than one person. Are you going to have to ask people questions? Are you going to have to record their responses? Could they be different responses? Could I drink 5 cups of water and another classmate only drink 2? Yes. So there is variability in there, and that is a statistical question. We have to gather data. B, where in town does our math teacher live? It's asking for a location, but just one location because it's only the math teacher, one person. So is there variability in the expected data? No. So is this a statistical question? No. Because it's only one person, one answer. There's a right answer and a wrong answer. C, how many minutes does it take students in my class to get ready for school in the morning? Okay, so we're asking for minutes. This would be a numerical data. And it's students, multiple students. So could there be variability in the data? Yes. Different students take longer to get ready for school in the morning. Is the question statistical? Yes. D, how many minutes of recess do 6th grade students have each day? So what do you think about this one? because we're talking about multiple students, right? There are multiple students, but, so multiple minutes, multiple students, but it's all sixth grade. Sixth grade goes out all at the same time, so they get the same amount of minutes. Is there variability expected in the data? Nope. It's all the same. So is this a statistical question? No. E, do all students in my class know what month it is? Do all students, we've got plural, know what month it is? This is a yes or no question. Yes, they do. No, they don't. So is there variability expected in the data? No. It's either yes or no. Is this a statistical question? No. We often collect data to answer questions about something. The data we collect may show variability, which means the data values are not all the same. So there's that word again. Data values not all the same is variability. Some data sets have more variability than others. Here are two sets of figures, A and B. Set A has more figures with the same shape, color, and size. Set B shows more figures with different shapes, colors, or sizes. So set B has a greater variability than set A. It's got more variety in B than we do in A. Both numerical and categorical data can show variability. Numerical sets can contain different numbers, and categorical sets can contain different categories or types. Again, numerical is numbers, categorical is categories or types. When a question can only be answered by using data, and we expect that data to have variability, we call it a statistical question. So there's our definition. A statistical question is a question that can only be answered by using data, and we expect that data to have variability. So to be statistical, it has to be answered by data, and have variability. To answer the question about books, we may need to count all of the books in each classroom of a school. The data we collect would likely show variability because we would expect each classroom to have a different number of books. So that would be a statistical question. In contrast, the question, how many books are in your classroom, is not a statistical question. If we collect data to answer the question, for example, by asking everyone in the class to count books, the data can be expected to show the same value. Likewise, if we ask all the students at a school where they go to school, that question is not a statistical question because the responses will be the same.